Hello, 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 hello everyone. Hello everyone. Today we shall discuss about class 11 physics. So here I am sharing something. You see here I am sharing note 3 and you will able to learn about it. So today we will discuss about these important things of class 11 physics, that is dimensional analysis. So here you can see today about the dimensional analysis, how we find the dimension of different things. Hello, hello, hello. So you see here how we are going to discuss all these things about dimensions in a. This is for class 11 CBSE board. First of all, I have to know how to represent dimension. To represent dimension, represent how we represent. Actually, in dimension, the length is represented by capital L, and mass is represented by capital M, and time is represented by capital T. And if you want to measure temperature, then temperature is represented by either K or theta, and current is represented by ampere. So these are the basic features of dimension. Hello, 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 hello. So here you can see what are the basic features of dimension. We have taken length as capital L, mass as capital M, and T as capital T, and temperature by K or theta, and current as ampere. Now if you want to find the different dimension, like number one is area. What is the formula for area? Is length into breadth. That is, dimension of capital L is L and dimension of breadth is B. So the dimension of area is L square. Suppose you want to find the volume. Suppose I want to find the volume, then volume will be L cube. That is length into breadth into height. So we are getting L into L into L, and that is we are going to get as L cube. And if you want to find the other factors like pressure, number 3 is pressure. Pressure is equal to force by area. Pressure is equal to force by area. Force, if you know the formula, force by area. And if you want to find the about force is equal to M into A, and by area. By area means L square. M is what? M is mass, and area, the unit of acceleration in meter per second square, so L t to the power minus 2 divided by L square. So the pressure will be M L to the power minus 1 t to the power minus 2. So this is the answer for pressure. In this way you can find all other dimensions. So today we learn about what are the different applications of dimension, what are the different importance of dimension, why we should use dimension. The first one is the most important is that we can find all the dimension like this, or suppose you want to find the dimension of velocity. To know the velocity you have to know the formula. The formula for velocity is displacement by time. Displacement upon time. Displacement upon time. So displacement can be written as L and T for T. So T T L T to the power minus 1. That is the dimension of velocity. We want to find the acceleration, dimension of acceleration. First have to know the formula. If you know the formula, then you can find out acceleration equal to dv dt, or rate of change of velocity with respect to time. So rate of change of velocity, so it will be L t to the power minus 1 by time. So it is L t to the power minus 2. In this way you can find all the dimension. Now what are the uses of dimension? That is our main concern. Now so there are some physical quantities which have no dimension, or you can say dimensionless quantities. And these are dimensionless quantities. They have no dimension. Dimensionless physical quantities. These are dimensionless physical quantities. That is, if there is a number, this is a dimensionless quantity. For example, if it is a pure number, it is a dimension. No pure number, so it is a no dimensionless physical quantity. Number two, if there is any ratio, then it is also a dimensionless quantity. Number three, if it is any angle, it is also a dimensionless quantity. And if it is the Reynolds number, Avogadro number, all the numbers, that is Reynolds number, or you can say that Avogadro number, these are all Avogadro, Reynolds number, pi, these are all dimensionless quantities. Number 7 is trigonometric functions. Trigonometric functions. These are also dimensionless constant. Sin theta, cos theta, all are dimensionless constant. Number 8 is exponential function. Exponential function. These are all dimensionless quantities. Or you can say number 9 as a logarithmic function. So these are all dimensionless logarithmic function. These are what we call it as dimensionless constant, or there is no dimension for these quantities. So you have to remember that these quantities have no dimension. That is student function, exponential function, logarithmic function, pure number, ratio, angle, Reynolds number, Avogadro number, pi. So these are the dimensionless physical quantities. Besides that, you get other important factors, and that is dimensional formula and dimensional equations. What is that? There is an equation obtained by equating a physical quantity with a dimensional formula is called dimensional equation of the physical quantity. Right? Later on we will discuss all these things. Dimensional analysis and its application. What are the main applications of dimension that we are going to discuss today? What are the applications of dimension? Main applications of dimension. What are the applications of dimension? Applications of dimension. The main important applications of dimensions are: number 1 is to check dimensional correctness of any physical quantity. To check dimensional correctness, to check dimensional correctness of any physical quantity. Dimensional correctness of any physical quantity. So these are the important factors for deciding this one. So you see here that you'll get all these things. These are the important factors to check the dimensional correctness. Dimensional correctness of any physical quantity, physical quantity. So this is to check dimensional correctness of any physical quantity. For example, we can write that A is equal to ut plus half at, A is equal to ut plus half at square. So if we find the dimension on left hand side, dimension of LHS left hand side, so it is displacement or it is L. And what is the dimension on right hand side? So we will find the dimension of RHS of right hand side. So A ut, E means what? Velocity. velocity is L t to the power minus 1 divided by into t, so it is L. And half, it is called, half is a number, so it has no dimension. Acceleration meter per second is called L t to the power minus 2 into time, so half a t square, so it is t square, so we are getting here L plus L, that is equal to L. So here is I find that the dimension of left hand side equal to the dimension of right hand side, right? So dimension of left hand side, dimension of left hand side, or LHS, is equal to dimension of right hand side is equal to dimension of right hand side. So you can see here that both the formulas are correct. You can see that both the formulas are correct. So both the equations are left hand side and right hand side are equal. Therefore we can say that the formula is correct. So you can say that the formula is correct, right? Then we can say that the formula is correct. The formula is correct. So if the dimension of left hand side and right hand side is equal, then we can say that the formula is correct. Now the second important thing is that to convert number 2 is this is for first application. Number 2 is to convert and that is number 2, what we can find that to convert any physical, number 2 is to convert any physical quantity, to convert any physical quantity from one system of units to another system of units, to another system of units, to another system of units, another system of units, another system of units. Should apply the formula here as n1 e1 equal to n2 u2, right? That is n1 e1 equal to n2 into u2. We will apply this formula. What are n1, n2? n1 and n2 are the magnitudes. Here where n1 and n2 are the magnitudes, and e1 and u2 and e1 u2 are the units of any physical. Units are the units of any physical quantity. Units of any physical quantity. Units of physical quantity in two systems of units. So this is the second use. So first important use is that application is to check dimensional correctness of any physical quantity. Number 2 is to convert any physical quantity from one system of units to another system of units. And number 3, what we find is this one. What is that? Number 3 is like this. Number 3, we can find here as to find a relation between interdependent physical quantities. To find a relation between between interdependent quantities. Interdependent, interdependent, interdependent physical quantities, physical quantities, physical quantities, physical quantities, right? And what we'll find here, so let Q, let capital Q, capital Q is a physical quantity, is a physical quantity, is a physical quantity. Let Q is a physical quantity, physical quantity which depends on, which depends on, which depends on x, y and z, and z, then Q will be equal to, then Q will be equal to function of x, y and z. So here we can write here as that Q is directly proportional, Q is directly proportional to x, number Q is directly proportional to y, Q is directly proportional to z. So if we combine all the three, then we are getting the value x to the power a, say x to the power a, x to the y to the power b, z to the power c. So if we combine all the three, then Q is directly proportional to x to the power a, y to the power b, z to the power c. This formula can be applied to find the relation between the different physical quantities. And you can find the powers and you will find the formula also. In this way we find all the things, right? And if they, so there are three uses of applications of this dimension. Number one is to check the dimensional correctness of any physical quantity. Number two, to convert a physical quantity from one system of units to that of another. And number three is to find a relation between interdependent physical quantities. So this one. So Q is directly proportional to x to the power a, y to the power p and z to the power c. So this is important, right? And the next important thing is that right, so we are able to find all the these important things, right? So you are finding and that this one, that Q is directly proportional to the power x to the power a, y to the power p and z to the power c. And we have some limitations of dimensional analysis also. So we learn about the various dimensional limitations. So here are the limitations of dimensional analysis. Limitations of dimensional analysis, of dimensional analysis. So what are these? In dimensional analysis we have three important points. These are the main dimensional analysis. What is first one is that we cannot determine we cannot determine the value of dimensionless constant. The value of dimensionless constant cannot find. For example, if I give an example to you that time period is simple period of 2 pi root over L by G. This 2 pi is a number we cannot find. We cannot find by dimension. We cannot find by dimension. We cannot find by dimension, right? Number two, what is the limitation is that when a physical quantity is a sum, the analysis fails. The analysis fails the analysis fails under the following under the following circumstances. Under the following circumstances. What are these? Number one is that when a physical quantity is the sum, when a physical quantity is the sum or difference sum or difference, that is b square plus that is b square plus 2as of two or more quantities So this analysis fails under the following. When a physical quantity is the sum or difference of two or more quantities, this analysis fails. This is the drawback, this is the limitations of dimensional analysis. Number two, there is another important thing when a physical depends when a physical quantity depends upon more than three physical quantities, So at this case also it fails. The analysis fails under the following two conditions: when a physical quantity is the sum or difference of two or more quantities. Number two, when a physical quantity depends upon more than three physical quantities, then it also fails. And number three, what we get here is that to derive a physical expression, to derive a physical expression involving trigonometric, logarithmic and exponential function. Logarithmic and exponential function. So these are the important points of dimension. And we have learned how to find the dimension. We already learned all these things. How to find the dimension, right? So these are the basic important things we have learned in case of dimension. Let us repeat it once again so that you can understand all the things. First one, you see the application of dimension. First one, how to find the dimension. What are the first important thing is this one, how to find dimension. First you write the formula, and length is represented as capital L, mass is represented capital M, time is represented capital T, and temperature is represented capital K or theta, current as capital A. So velocity or displacement time L by T, L to the minus 1. Acceleration dvdt, rate of change of velocity with respect to time L to the minus 1 by T, L to the minus 2. Area, length into base, so L into L, it is L square. Volume, that is L into B into H, L into L into L cube. Pressure is the force by area. F equal to ma, M is M. The dimension of acceleration is L to the minus 2 by L square, so M, L to the minus 1 to the minus 2. This is the, in this way you can find the dimension of many physical quantities, right? Now we will go to the next session, the next thing, that is dimensionless physical quantities. What is that? Dimensionless physical quantities. These are the dimensionless. If there is a pure number or ratio or angle, Reynolds number, Avogadro number, pi, trigonometric function, exponential function, logarithmic function, these are dimensionless physical quantities, right? And number three is that of what are the applications of dimension, that we are going to discuss in this. To check dimensional correctness of any physical quantity, whether this formula is correct or not, you can find by dimension. So S equal ut plus half t square. What is the dimension of left hand side? That is L. What is the dimension of right hand side? That is also L. So dimension of left hand side and dimension of right hand side is equal. So you can say the formula is correct. Number 2, what you find is to convert any physical quantity from one system of units to another system of units. We can find that is by the formula n1 u1 equal to n2 into u2, where n1 and n2 are the magnitudes and u1 u2 are the units of any physical quantity into systems of units, that you can find. Number 3, to find a relation between interdependent physical quantities. Let q is a physical quantity which depends on x, y, z, then q is directly proportional to function of x, y, z, q is proportional to x to the power a, q is proportional to y to the power b, q is proportional to z to the power c. So we combine all these three, then we are getting that q is proportional to x to the power a, y to the power b, and z to the power c, right? So we'll get it here as, right? So we'll find that next important thing is limitations of dimension analysis. So what are the main limitations of dimension analysis? We cannot determine the value of dimension as constant t equal to 2 pi root over L by g. For example, in 2 pi you cannot find the value 2 pi by dimension, because this is a dimensionless constant. Number 2, the analysis fails under the following 3 circumstances. Number 1, when a physical quantity is the sum or difference of 2 or more quantities, the analysis fails. Number 2 is when a physical quantity depends upon more than 3 physical quantities, the analysis fails. And number 3 is to derive a physical expression involving trigonometric, logarithmic, and exponential functions, it also fails. So these are the various limitations of these physical quantities, right? These are the various limitations you can find, right? In this way you will find that these are the, what we discussed today is about the various uses of dimension, how to find the various dimension of physical quantities, what are the uses or applications of dimension, and we also discussed the limitations of dimensional analysis. If you find any other chapters, then comment on the section so that we make a video for you on that chapter. Thank you everybody for watching this video. Thank you. So today we are ending this session. In the next session we will do whatever you comment, and that was going to be in the next, we will meet in the next session. Thank you everybody for watching this video.